this moment when you realize something new, a new understanding about a common phenomena. And then it opens all this window of possibilities of new questions to be explored. And sometimes there are traditional concepts that we go and argue with, and we open this question again. So how do we look at this phenomenon now with the matured knowledge, with the advanced methods that we have now, and with the multidisciplinary collaborations that we have that allows us to look at common and known processes in a very different point of view. My research looks into how a charge is transported across interfaces, and specifically we are looking at metal plating, which is not new. However, now we have a new way to look at these processes, to look at the electrochemical processes on the surface, and to apply these insights into the realization of more sustainable batteries using the most abundant elements on Earth, such as calcium and sodium. We are specifically interested in localized reactions on the interface. And now, interfaces, and specifically in batteries, tend to be very heterogeneous. And as a result, the interface is heterogeneous, and then the charge transport is heterogeneous, which means that the current density varies across the surface. Now, this might cause an uneven plating and even formation of short circuits in batteries, which is important both for future technologies but also for today's batteries, and is critical to make our batteries safer. And this is essential to meet our climate goals and essential to enable electrification. Now, each project will have a component of fundamental studies, a component of method development, and this is because the questions we ask, often we don't have the tools to answer them. And now, at last, there's always an aspect of applicable side of research. So, to use the insights we get from our fundamental studies to address real-life problems. I did my PhD in undergrad in Israel, and then I worked in industry in Israel, which was very different, and I learned from this journey and from moving from different environments about how it is, about the challenges of fitting in, especially for people who have unusual career route, and especially for people who come from a less represented background, and how difficult it could be to fit in, and how difficult it is also to change your route. I'm a new academic. I'm starting my group this year. However, I work with students in Cambridge for the last 5 years, and I developed multiple collaborations in Cambridge and also outside Cambridge in the battery and the chemistry community. And I look forward to develop a group that will do multidisciplinary research and collaborate with scientists internationally and in the national battery field, but also beyond battery field, looking at electrified interfaces and how we can apply the tools that we will develop to broader context of different questions that are critical today to address problems of significant societal impact. When I moved to Cambridge, the cultural shock I had was actually a good cultural shock, and I was amazed how inspiring and wonderful it is to be in a community of people who are excited and interested in science, as I am. This is I think this is underestimated, how important it is to have support from colleagues, and how important it is to share this enthusiasm, to share this interest, and to be encouraged into exploring more and further. And so for me that was a very good change, but that was definitely a change.